Assalamu alaikum. This is a question on simple harmonic motion. A uniform meter stick pivoted at 10 centimeter mark oscillating. Find the period of oscillation. So basically we have a pivot point and we have a meter stick, and this meter stick is pivoted at the mark of 10 centimeter. Of course, this is marked until 100 centimeter. And the center of mass of this will be at the 50 centimeter. So this is basically a meter stick, which meter stick can be simplified as a thin rod. Now we need the period of oscillation of this system, which is basically called the physical pendulum. So it is 2 pi the square root of I, the rotational inertia, divided by mgh. So we need to find the rotational inertia of this meter stick relative to the pivot point here. So relative to the pivot point here, we know the rotational inertia relative to the center of mass. So I, center of mass of the thin rod, is 1/12 ml square. But we can utilize what's called the parallel axis theorem. To get rotational inertia I relative to the pivot point. We'll call it O here, pivot point. So I relative to the pivot point is the I at the center of mass plus mh square, where m is the mass and h is the distance between the pivot point and the center of mass. So this is h. So now I will be 1/12 ml square plus mh square. Now we can substitute this result here for the rotational inertia of the meter stick in the period t equal 2 pi square root of 1/12 ml square plus mh square divided by mgh. Now the mass can be cancelled from all terms. So we are left with 2 pi square root of L square is the whole length of 1 meter divided by, in meter, 100 centimeter. This is in meter, is 1 meter. 1/12. So this is L square plus h square, which is the distance between the pivot point and the center of mass, which is between 0.1 meters or 10 centimeters to 50 centimeters. So it is 0.4 meters. So we can here say it's 0.4 square divided by 9.8 multiplied by 0.4, and this will give a period of 1.57 seconds. Thank you.